Hello everyone, today my name is Rifan and today I'm going to record a video on ratio. Contents that we're going to be covering over today: ratio rules with some examples, conversion of other forms of ratio and vice versa, practice questions for ratio, common misconceptions that students make, other strategies to tackle ratio questions, what is ratio and how does it help in our daily lives. Ratio rules. Rule number 1, we do not need units. Rule number 2, if you want to make the ratio smaller, you have to divide both numbers in the ratio by the same value. You may be really confused. But I'll explain it very later. Rule number 3, if you want to make the ratio bigger, you have to multiply both the numbers in the ratio by the same value, but you cannot add or minus. Rule number 4, ratio is always respective. For example, the ratio Tim had to Tom is 3:1. The Tim refers to the 3, the Tom refers to the 1. So that's what I mean by the ratio is always respective. Let me elaborate rule 2, because if you might have not understood when I explained it at first. Example for rule 2, 4:4. Okay, how do I make it smaller? It's called simplification. So I divide 4 on both sides. When I take 4 divided by 4, I get 1. And on both sides. 3:6. This is a problem where it begins. So you may be wondering, I cannot divide, they both are not the same numbers. But they do have the same common factors. So they have the common factor of 3. This is the most simplest form. Next, 9:3. So the common factor is 3 as well. So divide by 3, 3:1. Now you may be wondering, for 3:6, for 4:4, right? Why can I not divide it by 2? Instead, why must I divide by 4? Is to simplify the ratio to the furthest point, so that it will make the question way more easier for us. Next example, 12:10. Divided by 2, 6:5. You may be wondering, how come this such a big ratio can only be divided by 2? That's because if it was divided by another big number, for example 3 or something, 12 divided by 3 is possible, will give a 4, but 10 divided by 3 will give me a decimal. It will be 10/3, which is a very long decimal. 50 is to 100. Oh my god, this seems so big. This is so hard. Oh my god. You may think that. But first, we have to break it up slowly. 50 is to 100. You can break it up simply by dividing it by 10, which will give 5:10. Since it's an easier number, we can work it out more easily and divide it by 5. 1:2. Rule number 3. If you want to make a ratio bigger, you have to multiply both of the numbers. What I mean is, 4:4, you multiply by 4, which will give you 12:12. 3:6, if you want to multiply, it will be 15:30, and so on and so on. You may be wondering, why would we need to make the ratio bigger? Well, in some questions, they will require to make a ratio bigger to fit. There's a type of question in ratio called repeated identity. You will have to make both ratios the same. So you either have to multiply or divide. Usually it's multiply the number to make it the same. Conversion of ratio. The main thing for ratio is basically fraction. The fraction can be broken down into ratio, decimal, or percentage. But what we are going through now is the ratio. Fractions to ratio. John had 3/8 or 3/8 marbles of what Jake had. Find out the ratio of what Paul had to the difference of what this was a mistaken name. I think it was supposed to be John had to what Paul had. So 3/8 is equal to 3:8. John had 3/8 marbles of what Jake had, which means that John refers to the 3 while Jake refers to the 8. So now 8 minus 3 is 5. That's the difference. Find out the ratio of what Paul had to the difference of what John and Jake had. So the difference is 3. John had 3, while the difference was 5. So it's 3:5. Ratio to fractions. Paul had 3:8 of the total marbles of what Evan and Paul had. Find out what fraction did Paul had to the difference of what Evan had to what Paul had. You may be confused. So list 3:8 from ratio to fractions, okay? 3:8, just like before, you see over here, 3/8 equals to 3:8, which means over here, 3:8 equals to 3/8. So 8 minus 3 will give me 5 units. So Paul over difference is 3/5, which is 3/5. Look at the graph below. The graph shows how many marbles each person had for 2 days. How many marbles did Tim had to Tom at day 1? This is an easy question. 5. 5 is the 6. Day 1. You see this day 1? And Tim is to Tom. So you have to look at these two. And they said how many marbles did Tim had to Tom, not Tom had to Tim. So it has to be 5:6. Question 1b. Look at the graph again. The graph shows how many marbles each person had for 2 days. How many marbles did Tim had to Tom at day 2? The answer is 5:7. Wait. Yeah, 5:7. Because at day 2, Tim and Tom had 5:7. Why can it not be 7:5? It's how many marbles did Tim had to Tom at day 2, just like day 1. Question 1c. Look at the graph again. The graph shows how many marbles each person had for 2 days. How many marbles did Tim had to Evan at day 1? Tim is 5. Evan is 3. So simply 5:3. Question 1d. Look at the graph again. The graph shows how many marbles each person had for 2 days again. How many marbles did Evan had to Tom at day 2? Evan is to Tom. Day 2. 7:3. Oh, wait. It's not 7:3, right? It is 3:7. You see what I did? I made a mistake. So that's why you have to be very careful with ratio. Let me ask you question 2. Tim had $15 while John had $10. What is the ratio of Tim is to John? Tim is to John is 15:10. That's the original ratio. But if I need to simplify it to the max, I divide it by 5. They both have a common factor of 5. Ha ha ha. So divide both sides by 5. 3:2. There's your answer. 3:2. John was 14 kg, while Evan was 16 kg. What is the ratio of John to Evan? Ooh. 14:16. They both have a common factor of 2. So I divide both of the sides by 2 and I get 7:8. Next question. 13 of the tables at Geraldine's restaurants are full and the other one table is empty. What is the ratio of number of empty tables to the number of full tables? Option 1, 14:13. Option 2, 1:13. Option 3, 26:2. Option 4, 30:13. What do you think the answer is? I'll give you a minute. You can pause. But the answer is 1:13. The reason why is 13 of the tables at Geraldine's restaurants are full and one other table is empty. The ratio of empty table is 1. Whoops, sorry. There we go. Question 5. The ratio of the number of marbles Jason had to Jack was 3:5. Okay, so Jack had 10 more marbles than Jason. How many marbles do they both have altogether? Ooh, that's kind of a lot of transitions. So the difference is 5 minus 3, which is 2 units. So it means 2 units has the equivalent to 10 marbles. So just find 1 unit, which is 10 divided by 2, which is 5. How many marbles do they both have altogether? It's basically 5 units plus 3 units, which is 8 units. So to find 8 units, and we already know 1 unit is 5, we need to take 5 times 8, which is 40. So the answer is therefore 40. Question 6. This is the hardest question that I created. The ratio of how much money Tim had to Evan at the start was 5:3. After Tim gave Evan $24, they both had the same amount of money. Then Evan gave 2 units of his money to charity. What is the total number of money Evan and Tim had in the end altogether? This is a lot of transitions. The total number of units is 8 units because 5 plus 3 is 8 units because of the ratio 5:3. They both had the same amount of money after Tim gave Evan $24, which means number of units per person in the end will be 8 divided by 2, which is 4. The number of units that Tim gave to Evan was basically 4 minus 3, which is 1 unit. You may be confused. Why? Because in the end, Tim will have 4 units, but at first, Evan will have 4 units in the end, but at first he had 3 units. So what is a unit exchanger? Which is 1 unit. So if that 1 unit is $24, 1 unit is $24. Then Evan gave 2 units of his money to charity. So the amount of money Evan had in the end was 24 times 2, because at first he had 4 at the end, right? He had 4 units, and then he gave 2 units away. So 4 minus 2 units is basically 2 units left. So $24 times 2 will give me $48. The amount of money Tim had in the end was $24 times 4, which is 96, because Tim didn't give any more money away. The total amount in the end is just add the two values, Tim and Evan, which is $96 plus $48, which is $144. That's the answer. So you may be wondering, ratio seems kind of familiar. Oh yes, it's a ratio. So let me just teach you how to use ratio in terms of models. Ryan and Claire had some marbles. The ratio of marbles that Ryan had to Claire is 4:3. Represent this ratio with a model. They usually won't ask questions like this, but I'm trying to explain to you how to draw a model. So Ryan, he will pretty basically have 4 units. 1, 2, 3, 4. Claire will have 3 units. 1, 2, 3. Common misconceptions that most of you students make when you're learning ratio. Tom had 5 marbles, while Evan had 3 marbles. What is the ratio of Evan to Tom? Wrong answer. 5:3. You may be thinking, it's just 5:3 because there's Tom and there's Evan. 5:3. So it's there. But it says Evan to Tom. This is a trick question that examiners like to ask sometimes. So Tom had 5 marbles while Evan had 3. But that's why the correct answer is 3:5. It's the other way around. Well, different ways to tackle ratio questions are to look carefully because of the previous example. Students make mistakes, very careless mistakes. To simplify faster, find the larger common factor to divide. You don't have to necessarily do this, but if you do, it's a bit faster. But if let's say you do not know a larger common factor to divide with, then you can just divide it slowly, like 2, 1, like slowly. You can convert fractions to ratio and other ways to solve the problem faster and in a more suitable manner for you. Also use models to represent the ratio in the question, as it will help you to visualize more easily. Why do we need ratio, and how does it help in our daily lives? Ratios occur frequently in our daily lives and help to simplify many of our interactions by putting numbers into perspective. Ratio allowed us to measure and express quantities by making them easier to understand. Blah 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 blah. You may be confused by what does this mean. It actually means that when our two ratios are together, when like two values are together, ratios help us to like simplify them. For example, you watch basketball. Do some people watch basketball, right? They will have a scoreboard, and usually it will say 1:1 or 1:5, usually something. So that is to help us keep track. If we do not have ratio, then it'll be very hard for us to keep track. So that's why we have ratio, and this is how it helps in our daily lives. Thank you. Don't forget to like and subscribe, smash the like button, and I'll create another video.